Hello, today we are discussing a problem or finding the solution using bisection method. In the previous video you have seen that bisection method is simply by the cutting the line equally at the center and we are finding the point as new root. For example, we know a function f of x is continuous in between in the interval a and b. For that, we consider here the interval 2 and b, that f of x is continuous in the interval. For example, it is as 8 in the interval 2 and 8, and it has root. The root lies in between in the interval 2 and 8. That means the function is crossing the x-axis, or the function is f of x is equal to 0 in the interval 2 and 8. In the bisection method, we are bisecting. We are cutting the line at the center, and we are finding the center point. For example, here in this 2 8 line, the center point we can find easily by x0 as 2 plus 8 by 2, which is equal to 5, right? For example, here in this line, this you can write this is 3 4 5 6 7 8. Then 1 2 3 4 5 6 points. 6 by 2 is 3, that means 1 2 3, that point. This is the center point. And here in the bisection method, now the new root is x0. Then, as you have seen in the previous video, we find f of x0 and see whether f of x0 is negative or positive. Depends on that we decide the new root again. And here we are solving one problem. Here we have to find the root of the equation f of x equal to x cube minus x minus 1, which is equal to 0. We are going to find the solution of this equation. For that, we have to find the interval, or we have to find the values of x on which the f of x crossing the x-axis. For that, for example, here we start with 0. We substitute x equal to 0, we will get minus 1. That means at x equal to 0, the function is minus. Then we will substitute x equal to 1, for example. Then f of 1, we will see that this is 1 minus 1 minus 1, which is equal to minus 1, right? That means still the function is below the x-axis. Okay, in the x-axis. For at 0, function is minus 1. Then for x equal to 1, it is again minus 1. Then we substitute f of 2 for x equal to 2. This is x equal to 1. Then x equal to 0. For x equal to 2, it becomes 2 into 2 cube minus 2 minus 1, which is equal to 2 into 2 into 2. 8. It becomes 8 minus 2 minus 1, which is equal to 5, right? Which is positive. At x equal to 2, now y becomes 5. Now y is here. That means the function is crossing in between it is crossing the x-axis in between 1 and 2 in between. So the interval is 1 and 2. So now we are finding the new root as x0, which is equal to 1 plus 2 by 2 according to bisection method. Now it becomes 3 by 2, which is equal to 1.5, right? 1.5. Now again we will find x naught equal to 1.5, then we will find f of x naught equal to f of 1.5 or f of 3 by 2, f of 3 by 2, f of 3 by 2. Now you can substitute that values in the f of x equation. You will get 3 by 2 whole cube minus 3 by 2 minus 1, which is equal to 3 into 3 into 3, 3 into 3, 9 and 27. 27 by 2 into 2, 4, 4 into 2, 8, right? Minus 3 by 2 minus 1, for that you can write minus of 3 plus 1, then it becomes 27 by 8 minus 5 by 2, which is equal to 14 by 16, is equal to 7 by 8. Okay, now you can see that this function f of x is positive for x not equal to, f of x is positive, this is positive, f of x is positive for x not equal to 1.5. that means the root lies in between. Now the root lies in between. Previously it was minus for minus 1, for then now it is positive for 1.5. Previously it was at 2, now we have reached at 1.25, it is positive. Now the root is crossing in between 1 and 1.5. then the next root we can write as x1, which is equal to 1 plus 1.5 by 2, which is equal to 1.25. then we will find f of x1 and we will continue this process until we get the exact approximate root, and we continue this process and finally we will get the root as 1.3282125, etc. and we will continue this procedure until we get two successive iterates are almost equal, or at least 3 decimal places are equal. Okay, this is the bisection method for finding the root of a transcendental equation, okay, or a polynomial equation. Thank you.